Suspended in the night sky, the moon seems like a silent companion, watching over Earth. But what if I told you that this celestial neighbor is not just a passive observer? The moon is an architect of life itself. Its gravitational pull shapes our oceans. Its phases guide ancient calendars, and its presence ensures the delicate balance that makes Earth habitable. The moon's story begins with a cataclysmic event over 4.5 billion years ago. Scientists believe that a Mars-sized body, known as Theia, collided with the early Earth. The impact was so massive that debris was ejected into space, eventually coalescing to form our moon. This collision not only created the moon but also tilted Earth's axis, laying the groundwork for the seasons we experience today. Without this ancient event, Earth as we know it might never have existed. By measuring the ages of lunar rocks, we know that the moon is about 4.6 billion years old, or about the same age as Earth. The distance between the Earth and its moon averages about 238,900 miles. The diameter of the moon is 2,160 miles. The moon's mass, the amount of material that makes up the moon, is about 1/80th of the Earth's mass. Because the force of gravity at the surface of an object is the result of the object's mass and size, the surface gravity of the moon is only 1/6 that of the Earth. The force gravity exerts on a person determines the person's weight. Even though your mass would be the same on Earth and the moon, if you weigh 132 pounds, 60 kilograms on Earth, you would weigh about 22 pounds, 10 kilograms on the moon. The rotation of the moon, the time it takes to spin once around on its own axis, takes the same amount of time as the moon takes to complete one orbit of the Earth, about 27.3 days. This means the moon's rotation is synchronized in a way that causes the moon to show the same face to the Earth at all times. One hemisphere always faces us, while the other always faces away. The lunar far side, aka the dark side, has been photographed only from spacecraft. The shape of the moon appears to change in a repeating cycle when viewed from the Earth because the amount of illuminated moon we see varies depending on the moon's position in relation to the Earth and the Sun. We see the full moon when the Sun is directly behind us, illuminating a full hemisphere of the moon when it is directly in front of us. The new moon, when the moon is darkened, occurs when the moon is almost directly between Earth and the Sun. The Sun's light illuminates only the far side of the moon, the side we can't see from Earth. The moon's gravitational pull on the Earth is the main cause of the rise and fall of ocean tides. The moon's gravitational pull causes two bulges of water on the Earth's oceans, one where ocean waters face the moon and the pull is strongest, and one where ocean waters face away from the moon and the pull is weakest. Both bulges cause high tides. These are high tides. As the Earth rotates, the bulges move around it, one always facing the moon, the other directly opposite. The combined forces of gravity, the Earth's rotation, and other factors usually cause two high tides and two low tides each day. The moon's gravitational pull acts as a stabilizing force, keeping Earth's axial tilt steady at around 23.5 degrees. This stability ensures predictable seasons, allowing ecosystems to adapt and thrive. But tides are more than just a rise and fall of water. They are lifelines for coastal ecosystems. Tidal pools become temporary habitats for marine life like crabs, starfish, and mollusks. Mangroves, which depend on tidal rhythms, protect coastlines from erosion and serve as nurseries for countless species. Billions of years ago, tides may have played a critical role in the origins of life itself. Scientists theorize that the constant mixing of water and nutrients in tidal zones created the perfect conditions for life to emerge. The moon, in its quiet way, might have been the first midwife to life on Earth. Tides, driven mostly by the moon's gravitational pull, would also change drastically. Without the moon, tidal ranges would shrink significantly, with only the sun's weaker influence remaining. This reduction would impact coastal ecosystems like mangroves, salt marshes, and tidal pools, which are vital for numerous marine species. The diminished tides would also slow the mixing of nutrients in the oceans, reducing biodiversity and collapsing marine food webs. This disruption would ripple through the global ecosystem, affecting everything from fish populations to human livelihoods that depend on the sea. The absence of the moon would likely have hindered the evolution of life itself. Tidal zones created by moon-driven tides are believed to have been crucial for early life forms. These areas provided dynamic environments where water, nutrients, and minerals mixed, creating opportunities for life to adapt and evolve. Without such zones, the emergence of complex life might have been delayed or even prevented altogether. Earth's rotation would also speed up without the moon. Over billions of years, the moon's gravitational forces have gradually slowed Earth's spin, giving us 24-hour days. Without this influence, Earth's days would be much shorter, lasting only 6 to 10 hours. This rapid rotation would disrupt the natural cycles of plants and animals, many of which rely on 24-hour rhythms for survival. Crops might struggle to grow efficiently, and ecosystems could collapse under the strain of a dramatically altered environment. The absence of the moon would also affect Earth's geology. The moon exerts tidal forces not only on our oceans but also on Earth's crust. This gravitational pull contributes slightly to tectonic activity, which replenishes essential minerals in the soil through volcanic eruptions. Without the moon, this delicate balance could shift, potentially reducing volcanic activity and impacting Earth's long-term geological cycles. Finally, the moon's gravitational pull helps maintain Earth's orbital balance around the sun. Without it, Earth's orbit could become unstable over millions of years, increasing the likelihood of catastrophic collisions with asteroids or other celestial bodies. The moon isn't just a passive observer in our sky. It's a key player in maintaining the delicate balance that makes Earth habitable. In short, the moon's influence extends far beyond its beauty in the night sky. It is a stabilizing force for Earth's climate, ecosystems, and even human culture. Without it, our planet would be a dramatically different and far less hospitable place.